Hello, class. Today we're going to be looking at lesson number 4, continuing surface area. We're going to look at how to use the equations on the formula sheet. Now I added the formula sheet to the back of last class's note, so April 17th. So you can look there, or you can find it as a separate file on the Google Classroom. The page you want to look at is going to be this page here. It gives you the formulas for the surface area of the corresponding shapes. So that's at the back of yesterday or Wednesday. No, this is coming out on 20th Monday. So on Friday's lesson, it's on the back of that. Okay, so I'm going to share my screen here. So the notes for lesson number 4, going to look at two shapes in particular, the cylinder and the cone. On your formula sheet, you have the cylinder, sphere, cone, square base, pyramid, and rectangular prism. We're going to look at all those shapes except for the sphere for now. I might have like a bonus question on the sphere, but I just wanted to focus more on the 4 other shapes as we don't have as much class time to go through everything. All right, so the formulas you have on your formula sheet, they break them down into the different shapes that your 3D object makes when you break it down into a net. So if you remember, a net is going to be this shape here, where we take a cylinder, we break it down into its 2-dimensional parts, so into the edge parts. So for a cylinder, we're left with one rectangle, where the side length is going to be the circumference of the top and bottom circle. Because as the rectangle wraps around the cylinder, it lets you go all the way around the circle. So the length is going to be the circumference, and then the height is going to be the height of the cylinder. So we have that one rectangle. We also have 2 circles, the top and the bottom of the shape. So we can break the 3-dimensional shape into a 2-dimensional net where we have 2 different shapes. So if you look at the equation in your formula sheet, we have the 3 parts. We have the top, the base, and the side. You may notice the top and the base are the same. That's going to be one circle and another circle, so pi r squared for the area of the top and pi r squared for the area of the bottom. So that's going to be the equation here. And we have 2 circles. So we get 2 times pi r squared. Because we got 2 circles, we're going to multiply our area by 2. The net shape we have is the rectangle. So what we have, it shows on the formula sheet, this is going to be this area of side. I have here area of rectangle. So the area of the rectangle is just the height times the length. Now the height we represent is just h, and the length is going to be 2 pi r, which is the circumference of the circle. Rearranging this so that we have our variables r and h last and our numbers first, we get 2 pi r times h. So that's just the circumference of the circle multiplied by the height of that rectangle. And then we get a total surface area. When we're taking area of 2 shapes or 2 or more shapes, we just want to add them together. So we get a total area is 2 pi r squared, which is going to be our top and bottom again, and then plus 2 pi r times h, which is going to be our rectangle. So below I give you an example of how we can use this equation. So whenever you're given a problem, you will either be given a diagram or you'll be given a word problem where it tells you the dimensions of the shape. First thing I want you to do is write down the dimensions as the variable. So here I wrote r equals 2 centimeters. That's my radius of my circle. And now the top and bottom circle will always be the same, or else it'll be a different shape. And h for my height of my cylinder. So we're given the radius of 2 centimeters, so r equals 2 centimeters. And then we're given a height of 3 centimeters, so h equals 3 centimeters. Now, using our area, we're just going to replace the r with 2 centimeters. So here we have 2 times pi times r squared, which we replace with 2 centimeters squared. And we want to make sure we square our units as well. And now we're going to add on our 2 times pi multiplied by our h, or multiplied by r, and our h for height. So this will be 2 pi times 2 centimeters times 3 centimeters. Now, just like how for my first part of my area equation, my centimeters are squared, my second part, my centimeters are also squared. So I have the centimeters multiplied by a centimeter, giving me centimeters squared. So here what I did, my next line, this is an optional step. Some questions might ask you to leave your answer in terms of pi, so you can do it this way. But you can just plug this all into your calculator if you prefer. I do recommend just solving for one part of the equation first, and then solving for the second part. A lot of mistakes happen with calculators if you try to enter everything at once. So solve for that first part, write the question down, and then add that second part, and then do the addition separately. What I did here is I did 2 multiplied by 2 squared, so that's 2 multiplied by 4, giving me 8 pi, and then my units at the end, centimeters squared. Here, on the second part for my rectangle, I got 2 multiplied by 2 multiplied by 3, giving me 12 pi, leaving pi as just a symbol, not put into number form yet, and my unit centimeters squared. Now I can add these together. When I add them together, add these two together, I have pi centimeters squared in both of them, meaning that they're like terms. And what I can do is I can just add the 8 and the 12 together and keep that pi centimeters squared off to the side for a second and then add it back on. So this gives me 10 pi centimeters squared, which now I could solve by entering 3.14 as pi, or I could even leave it as in this form if you prefer. So again, you don't have to do it this way. This is just a different way you can visualize it. You can just solve for the first part of your area equation and the second part of your area equation. And actually, as I'm saying this, one thing I noticed, I didn't write surface area here. This is surface area, not just area. Okay, so I was going to find a video that shows like the breakdown of a cone into its net. I couldn't find a good one, so I was hoping that you have your part of the assignment from Friday's lesson where I asked you to make a net of a cone. And if you could grab that out now so you could visualize what's happening. Because the net of the cone is a bit tricky. So as we move on from cylinder into the cone, the base of the cone we can see is a circle, just like a cylinder. But the top of the cone, or the side of the cone, isn't a nice triangle. It is part of a circle. So we can see that the curve on the circle, the length of that curve, is going to be the circumference of our base, just like it was for the cylinder. But it goes into a peak as kind of like a part of a triangle. So I think the easiest way to do it is just for me to give you the answer for this somewhat. I'm going to call it a half circle. It's not necessarily a half circle. Depends on the height and the side length of the cone. It could be more than half a circle. It could be a bit less than half a circle. It depends on the type of cone. So I'm just going to call it half a circle. The area of this half a circle is going to be pi times r times our side length. So our side length, if we have our cone, it's just going to be the length from the top along the side to the base. So our total area is going to be the area of our base circle, so pi r squared, plus the area of our half circle, which is going to be pi times our side length, s. So you can see this on your formula sheet as well. They call the area of the half circle, they call that the area of the side. And then the area of the circle, or what I call the area of the circle, they call the area of the base. So that's just like the base circle. And then the surface area, when we add those together, it's the same as what you find on your formula sheet. So moving on to an example here. again, I've given you a diagram where I've given you the radius of the circle and the side length of the cone. So again, the first step, I think a pretty important step, because I find sometimes you get, especially when you get more complex shapes, there's a lot of different numbers out there, and it's hard to realize what number to put where. So first step, we're going to say, okay, the radius, R, is going to be 10 centimeters, and the side length, S, is going to be 12 centimeters. So we can write these two shapes down, or sorry, write these two variables down, and then we can write down our surface area formula. So the surface area of a cone is going to be pi times r squared plus pi times r times s. Now we can take our variables and we can plug them in. So here we got pi times 10 squared, and we got a square of centimeters, plus pi times 10 times 12. Now, I just went ahead and had centimeters squared here, but this would be pi times 10 centimeters times 12 centimeters. I just kind of skipped ahead and took that centimeters squared out. Now, just like the last question, I solved this in terms of pi first. Again, you don't have to do that. You could just solve for the first part and then add the second part as well, instead of, or using pi as a number instead of using pi as a symbol. So here, 100 squared, 10 squared is going to be 100, so we have 100 pi centimeters squared. So that's going to be my area of my circle, my base. Now I'm going to add the surface area of that side of the cone, which is going to be 10 times 12, so 120 pi centimeters squared. So finding the total surface area, I'm going to add these two together, getting 220 pi centimeters squared, which is going to give me 690, or about 690 centimeters squared, for my total surface area. So there is 4 problems for you to complete out of the workbook. This is also in Google Classroom. 1B, question 4, question 5, and question 6. Try your best to get these right. I'm going to be going over them and giving you some feedback. Hopefully sooner rather than later, so you can see kind of if you're on the right track. And this is important stuff to learn as it's going to continue to help us when we move on to volume as well. What else do I want to say? So we're going to have a video call on Tuesday at 10 a.m. I'm considering moving one of the video calls to later in the afternoon. If you prefer a later time, if 10's too early for you, can you just shoot me an email just to say you'd like a later time, and if you have a suggestion what time you would prefer, add it into the email. So on Tuesday, video call at 10. Come with any questions if you have any. Again, it's just optional. I'm not going to go over any new content, but if you aren't too sure about these questions, we can even do it together. Kim will be on as well, and she can help you as well with some of the questions. Have a good rest of the day.
Okay, so I recorded it initially, and then I accidentally deleted my recording, but still had the video up, but then couldn't save it. So I'm hoping that this still worked. Yeah, we'll see. Okay, bye.